Okay, we're now going to look at some special types of factoring, more specific types of factoring. And right now we focus on polynomials of the form x squared plus bx plus c. So in other words, we have a squared term, an x term, and a number term, but the coefficient of the squared term right here is 1. Right? There's nothing in front of that one. To kind of motivate this discussion of why this works, consider a multiplication problem. Consider a multiplication problem where when we multiply this out, it will end up in that form. We know that we're going to get an x squared term because we'll have an x times an x, if you remember your multiplication process. So as we multiply this out, we'd have x times x is x squared, and then we'd have x times 8 is 8x, and then 3 times x is 3x, and then finally 3 times 8 is 24. And you can see now if we combine our like terms, this will fit that format that I've just described above. 8x and 3x becomes 11x and 24. Now our goal in factoring is asking the question, how can we take this polynomial here, x squared plus 11x plus 24, and go backwards to write it in its factored form? Well, a couple of things I want you to notice here. If we're dealing with the 4-term form, right, that's a 4-term polynomial, and we've talked about factoring by grouping. So what I want you to see here is if it's written in its 4-term form, that we can do our grouping. All right, take out our common factor for the first two. Take out our common factor for the second two. And then we can pull out that common factor of x plus 8. It's in both of them. And we'd end up with x plus 8 and x plus 3. But what I want you to see here is, hold on a minute. Hold on just 1 minute. Right, that 8 and 3 are just the coefficients of the middle terms. So if we can figure out the coefficients on those middle terms, what they should be, then we can actually figure out the factored form. So our question now becomes, how do we figure that out? So again, our question is, given this, how can we figure out that the two numbers that we need to make up that 11 have to be 8 and 3? We know that right now because we multiplied the problem out. Well, here's, if we think about where each of these numbers came from, each of these pieces came from. The x squared came because we did x times x. So we know that we have to have an x and an x in each of our terms. Move over here to the 24. The 24 came about because of 3 times 8. But if we're looking at the 24, then we need to go a little further because there's lots of other things that multiply to a 24. So the question becomes, how can we pick out that it's 3 and 8 just because we know they multiply by 24? Well, if that was the only information we had, then we couldn't decide that it had to be 3 and 8. But we have one other piece of information, and that is the middle term. The middle term adds up to be 11, and of all the factors of 24, the pairs that multiply to be 24, the only thing that multiplies or adds to be 11 is 8 and 3. And so when we're factoring something like x squared plus bx plus c, what we're going to be looking for is a pair of numbers that multiplies to give us that number c, but then also adds to give us that number b. And if we can find that pair of numbers, then we could rewrite it in its four-term form, but rewriting it in its four-term form for these problems, well, again, notice those numbers are just right there. So once we find the two numbers, we can actually write out the factors, x plus the first one, x plus the second one. And so that's the process that we're going to be using as we do some examples in future videos. So stay tuned to those.